All right, everybody. So I think this is our fourth session, maybe, and we're talking today about the psychology and sociology section of the MCAT. Here's the link for the study group. I'm sure everybody here is already in it. So what I'm going to start doing is recording these sessions and posting them on a YouTube channel. So if you missed the last session, which was about cars, I think it was a really good session. You can watch. We went through the logic of the section, and then we actually went through a passage, and it was pretty entertaining because I think everybody was convinced it was one answer, but it wasn't. And then once we realized the rationale, everybody was like, "Oh yeah, that makes sense." So it's a bit tricky, and it's good to see how to get there. So yeah, I'm just gonna start recording these so that if you miss a session, you can go back and watch it. And yeah, so today's session is psychology and sociology. Okay, so just to generally talk about this section, um, none of the sections are easy, but I think that this section is the most straightforward because it's really just a rudimentary knowledge check and experimental thinking check. So all you need to do for success in this section is know your stuff, know your vocabulary, know your sociological, psychological concepts, know some of the theories, things like that. So that's like 50% of the battle, just like studying enough to like know everything. And that's like, reading and memorization. That's probably the easiest stuff that you can do to prepare for this exam in general. The harder part is the experimental thinking and data interpretation. And because those are skills, you can't just memorize your way into understanding a graph or something, right? So those are skills that you will practice and get better at, and you'll learn ways to understand. You'll start seeing patterns and it will become more familiar to you. This is especially where, like, if you have any experience with actual research, it will help you a lot because especially if it was like real research where you guys were going over like other scientific studies and data and making your own data and stuff like that, that will help you a lot. But if you didn't, like me, you're gonna have to like learn this stuff and like all the terms and concepts from scratch. And it's weird because like even though this is such a big portion of the MCAT, it's actually beyond the section because it permeates to the biology and biochem section, and even sometimes in the chemistry and physics section, you might get an experimental passage like this. So it's such a huge part, but like nobody really teaches it like they teach the content, which is strange to me. Or maybe I just haven't found a good resource for it, but this is definitely something that you want to get good at. It's important to get good at this. Okay, so okay, so like I just touched on, you need to study terms and vocabulary, how you conduct experiments and how you go through experiments, and how to interpret experiments. So the first half of it is learning all the material, right? So we have this, so there's a link here so basically Khan Academy has like a bunch of videos that covers everything that you need to know from psychology and sociology for the MCAT, right? And fortunately, previous people have like written up a notes version of all of the videos. So you can read if reading notes is faster than watching all the videos, you can read through the notes. And the comprehensive version of this thing is 300 pages long, and there's a condensed version that's 80 pages long. So I can give you guys the link. I think somebody is unmuted. So there's a link in the chat, and so this is basically a notes version of the Khan Academy videos. Now, remember what the purpose of this thing actually is. Reading is not a guarantee that you'll actually understand or remember anything. And that's what you need to have. I remember last session, somebody talked about, I think they were like something, it was some term, cognitive dissonance. Like they were familiar with the term, but not enough to like answer a question. So this reading about something is just to familiarize yourself with the concept or with the theory or whatever it is, right? But the actual learning, we're going to get to how do you actually learn this stuff once you familiarize yourself with it. So these notes and then these notes also. So remember the outline that I gave you guys before. This is just another source for you to like learn the material, right? We're just talking about exposing, because I'm not sure about you guys, but a lot of this material I had never seen before. And I had only taken, to be fair, I had only taken like 2 intro psych classes and like, I think 1 intro to sociology class. And so a lot of this, and that was like in freshman year for me. So a lot of this stuff I was like, whoa, did I even learn this? Or so I really had to like self-teach myself a lot of this. And the good thing is there's a lot of resources for you to self-learn it. It's just you should just be prepared for that, because like I assume if you're pre-med, you're probably doing a lot of hard science classes, and this is not maybe not so readily available unless you're doing like a psych degree or something, or a psych minor. Okay, so this source is also really good. They have really nice articles about all the stuff that you want, and they have really great diagrams and pictures. The only thing is sometimes the articles are a bit long-winded and they have background that you don't need to know because they present it kind of like a textbook, I guess. But it's so well organized that it's just a great resource for you to learn anything. And the Khan Academy document is like comprehensive, but a little bit unorganized because like, some students made it. So it's just a trade-off. If you don't get what you need from one document, then go to this one and see if you see it instead. Okay, so this is the section where you kind of need to use flashcards. And I say that you need to use flashcards because there's so much material, there's so much vocabulary. Like this is the section that's testing your memorization the most, because there's so many random terms and concepts and stuff that people just made, and like you just need to know the definition to them. It's not, the critical thinking comes after you know the definition. So if you don't know the definition, then you're just kind of stuck. And so this is where you need to spend a lot of time on flashcards, because flashcards are how you can actively test yourself. Like if you read about cognitive dissonance, you read an article about it, that's fine, but you haven't actively tested yourself if you actually know what cognitive dissonance is. You just read it passively. So you would have to actually go back later and do a flashcard or a practice problem or something that tests, well, do I actually know what this is? And so I'm going to talk a little bit here about this program called Anki. And Anki is a really, really powerful and versatile flashcard program, basically. And med students and tons of other students use this program around the world, and you can use it for anything because it just gives you flashcards. But the secret sauce about Anki is if you look in the bottom right corner here, you'll see 3 buttons. Like, so this is a window of what Anki looks like, right? So the top over the line, this is just somebody is using it to learn like French vocabulary, right? So the top over the line is the card that you would see. And the bottom is the definition, right? So this person has just clicked this card and he sees the definition, right? And now he gets to say how easy it was for him to answer this card. So he's got 3 options. You can say again, or good, or easy. And you notice above those options, there's a little time interval. What that does is, depending on what you select, the program is automatically going to say, okay, I will show you this card again in 1 minute or 10 minutes or 4 days. And the reason that's valuable is because you're going to end up having to do hundreds of cards, because there's just that much stuff. And you need to minimize the time that you spend on cards that you don't need to see. If you already know, like let's say you took like a neurobio class, right? And you already know like the brain anatomy pretty well, then you don't need to be reviewing that section a lot. And this is an extension of that whole diagnostic scheduling system I showed you guys before, where like you focus on the stuff that you're weak at and you don't focus on the stuff that you're good at, right? So, or rather than don't focus, you focus less on the stuff that you're good at. So the point of this is that if you, so like I was saying, if you know like brain anatomy is part of this section, right? If you already know it, then you can just go through those cards and be like, I'll review these in 4 days because I already know them well. So then you wouldn't waste 3 days reviewing those cards because you don't need to. Whereas if you're struggling with like, I don't know, like stages of development because you never learned it, then you would spend a little bit more time. And so the time that you saved on stuff that you already know, you can dedicate it to stuff that you don't know. So that's all well and good, right? So this is different from regular cards or like Quizlet or whatever, because those don't have that feature of, this is called spaced repetition, because it's spacing out when you repeat a card. So it gives you, you know, like I said, you spend more time on the stuff that's harder for you and less time on the stuff that's easier for you. The problem is that this program is not very intuitive at all. It's quite arcane in a lot of ways. And so I'm just introducing it to you guys because it was invaluable for me to learn, and I'll show you why. But either way, you're gonna, even if you don't use Anki, that's fine, but you're gonna have to spend flashcards and they won't have spaced repetition. That's all I'm saying. I'm not trying to force this onto you because it is difficult to use. And if you're not really like a computer person or anything like that, they have it on the phones too, but like it's hard to like edit cards on your phone and stuff. So it's like, if it's not something for you, then that's fine. I just want to expose it to you guys if you want the option of using it. But I will make like a video or something on this. So if you want to use it, you could take a look at it and see if it works for you. So I want to show you an example of how it works. So here, this is a card. This is a real card that I pulled from my Anki deck. And essentially, it is just asking me like, what are Freud's stages of development, right? And I put in parentheses 5 to give me a little trigger to know, okay, there are 5 different answers that I should have here. And so then I'm going to think about, you know, if I was studying, I would be like, okay, let me list them out. So I would know that 0 to 1 is, oh, actually, I'm not sure how much of this I remember. Let's see. I think 0 to 1 is oral. 1 to 2 is anal, I think. Then 3 to 6 is like phallic or something. 3 to 6 maybe. And then 6 to 12 might be like latent. And 12 plus might be genital. I think those are what they are. Let's see how close I was. So this is what I just did right now is exactly what I would do if I was studying with flashcards, right? Obviously. So then I would look here and see what I see. And okay, I was close. I said 1 to 2 for anal. It was actually 1 to 3, I think. Yeah. So what I just did there was I just reviewed the card and I checked myself, like, do I actually know this, right? Compared to if I had actually read this, like, read it, you guys are reading it right now, that doesn't mean that you know it, right? Like if I cover the thing, like, can you tell me what it is? Like, if you can like recall it, like what I did was recall it from my own brain, then you actually learned it, right? And so, oh, but I missed this part, right? If a child does not resolve the conflict, he becomes fixated at this stage and struggles with it later in life. That's important, right? So it's like, I would, by my own measurement, I would say like, I feel like I know this card, you know, decently, but like not perfectly. I struggle with it a little bit. So then in that case, I would say like, I would probably hit like, oh, medium. I know this medium well. No, it wasn't easy. It wasn't hard. So I'd like to see it in a medium frame of time again. So just to understand like why, so this is just general advice about like making good flashcards. It doesn't necessarily apply to Anki, it could apply to anything. Why did I not break up the card, right? And I've seen this before. I've seen people put this as like, okay, the front of the card would be like, what is the first stage of Freud? Then what is the second stage of Freud? What is the third stage of Freud? Or whatever stages of anything, right? And the reason that I don't like that is because learning discrete information is harder than learning information that is bundled together or associated together, right? And that's just because of how our brain works. Our brain works with the semantically linked concept maps, right? We have these schemas in our mind, and you'll actually learn about this as you review the section. And this is, and the other thing is that you won't, okay, so this is a little tricky. Why do I not show the stages, right? Like, why don't I just put like, tell me about the oral stage of fruit, right? Because, and the reason I don't do that is because sometimes you need to recall the stages. Sometimes you need to know what the stages themselves are, and other times you just need to recognize them. So what do I mean by that? I mean that sometimes, and this is something that you'll notice when you do questions and stuff. Some things they want you to be able to recall directly in entirety, and other times you're just supposed to, just recognizing them is enough. So you can like customize your approach to fit that. What do I mean by that? This is another flashcard that I have, and this is all of the theories of motivation that you need to know for the MCAT, right? So why have I done it like so let's point out a couple things. First off, actually wait, before I dive into this part, does anybody have any questions? Because we did a bunch of stuff over here. Any questions on like Anki or making flashcards or whatever I'm talking about, or anything? I don't know. No, all good? None at the moment. Okay. All right. If anybody has any questions, just I don't know, post something in the chat or anything, and I'll stop and I'll address your question. So okay. So here I'm talking about all of the theories of motivation on the MCAT. On the MCAT, right? And so so this is again a real card that I pulled from my deck, right? Notice how drive reduction theory has this like blue square on, right? And that's because I've occluded the answer, right? Because this is a flashcard asking me, hey, do you know what drive reduction theory is? So why do I present it this way with all the other theories? Why don't I just do a card that says, you know, the front is drive reduction theory and the back is some other, the definition, right? Why do I present everything at once? Well, the reason is because the MCAT is going to make you compare and contrast these things. Anytime you're dealing with a theories that, like, because these are all different takes on what motivates humans, right? What motivates behavior. These are all different theories. So the MCAT is not only going to want you to know, like, hey, do you know all of these theories, but do you know how they differ? Do you know how they compare and contrast, right? So rather than like learn them all individually and then be blindsided when you're taking the test, learn them all in at once in like comparing with each other. And then when you get to the test, you're like, okay, I know all of these as a set, so I can kind of compare. I've already been comparing and contrasting them, right? So that's why I bundled them all together here. And so the other important thing is I don't hide all of the answers at the same time, right? That would be like, okay, name all of the theories at once. That's impossible. That's like really, really hard and that's also not an effective way to learn. Because memory is best when your retention is best when you're recalling a small, simple fact that's easy, that is like low cognitive load, I guess to say. So I don't make this card, I wouldn't make the front of this card like, hey, name all of the theories of motivation and explain all of them. That's just too much. And the other thing is here, you'll notice that unlike the other card, unlike this card, I didn't hide the names of the theories because they will give you the names of the theories. Because in the questions will have that as an answer of like, what does this situation most represent? And the answer might be drive reduction theory or expectancy theory or incentive theory and stuff like that. So in that point, your goal is to recognize a phrase and know the definition. And that's what the flashcards are there to help you for. When you see a phrase, you're supposed to immediately be able to recall what that means, and not on its own. You're supposed to be able to recall what it means in the context of the related things, so that you're able to compare and contrast. Um, so so if I was doing this, right, I would be like, okay, what is drive reduction theory? Let me think about it, right? And I would say, well, human drives, right? I would think about um, what's coming to mind is like our innate drive for uh, certain needs that we have. But then again, then I see, I'm like, wait, I brought up needs, but then there's a need-based theory here. So am I getting things confused? And I would look at this and be like, motivated to full physiological needs, but also higher level emotional needs creates a drive. So I'm like, okay, interesting. These are kind of related. So I want to separate what I'm saying, right? And then I'm thinking about drive reduction theory. I think it was related to reducing like uncomfortable stimuli and like returning to homeostasis. So so I would click on my card and I would look at like the definition, right? They said aroused internal state created by a physiological need, unpleasant drive associated, gives you negative reinforcement. Okay, so I've got this whole little thing here, and I'm like, restore homeostasis is an example of drive reduction theory. So I was able to, so this is why I put this this little map here, right? When you see a term, you should be able to like link it well to another term that you understand. So when I saw drive reduction theory, I was able to link it to homeostasis. And that is like, I would say like is almost good enough. Like, even if you can't remember all of this, if you can remember like an example of it, then you're in like a decent enough spot. Because if you see drive reduction theory on as an answer choice, at least you won't be like, what the hell is this? At least you'll be able to say, okay, I know homeostasis is an example of drive reduction theory. So what can I do with that? Right? So you want to be able to like convert these terms into definitions that make sense to you, if that makes any sense. And so then I have like a picture here on the bottom to help me like, okay, drive reduction theory looks like this, blah, blah, blah. And then I would review the card according to how I did. Yeah. And so here we have, this is like a real AMC question. I think I just grabbed it from somewhere. And this is exactly why I make the card the way that I did, comparing all the theories, because that's what you're asked to do, compare all of these different theories, right? And so the question is like, the tendency of bystanders to avoid intervening in conflict, even though they would want others to intervene on their behalf, can best be explained by what? So here I would look, so what you can do is look through each choice and be like, okay, what does this mean? And then what does this mean in relation to the question, right? Opponent process theory. I honestly don't remember what this is. I think it's something about like eye color, something about, no, actually there's two of these things, but I forget there's one related to drugs, I think, and there's one related to eye color. I actually totally forgot this. Does anyone remember what opponent process theory is? I actually completely forgot this, but I don't think it applies to this question. Cognitive dissonance theory. I think that this is a good choice because because the bystanders' beliefs are contradicting with their actions, right? And that's what cognitive dissonance theory is. When your beliefs or like your morality, your morals are not in flow with your actions. So I think this is good. Drive reduction theory. We just talked about drive reduction theory. It's about returning to homeostasis. It's about eliminating annoying drives that you have. So for example, if you really have to go to the bathroom, that causes you some kind of discomfort, right? So you go to the bathroom and then you've lost your discomfort. So that was a drive that made you do an action. So you reduce the uncomfortableness of the drive. So that's one theory of human motivation. Then expectancy value theory. This is really about like incentive. Well, no, you have to be very careful with these things. So what I just did there is I mixed up two things, right? Expectancy theory of motivation and incentive theory. These are two separate things. So this is why this is good to have everything in one spot, because you can immediately be like, okay, I'm mixing things up. And you can, it's very important to be able to keep things discrete and not mix them up because they mean different things. So I was about to say expectancy theory was incentive theory, but then I remembered, oh wait, there's an incentive theory. So it's not that, right? So then I look back here, individuals are motivated to act based on their expectation of the results of the behavior. So that's actually a completely different thing. And I don't think that really matches here because the actions are not in line with the expectations, really. So I think cognitive dissonance is a correct answer here. I'm not actually sure what is the correct answer, but I believe that this would be it because I don't think opponent process is correct. But yeah, I believe that cognitive dissonance theory should be right. Any questions so far? Okay, so basically, like I'm saying, the first, I mean, not the first half, but like half of this test is like this vocab check, like this, like, do you understand these things well enough to, and honestly, this is probably like the most simple part of the MCAT, like these style of questions, because it's just like, are you prepared or not? That's it. Like it's not really like that you prepare and then you get confused when you get here. You just prepare, and if you prepared enough, if you put in the time, then you should be okay with these. So for me, this is why I like that this section is like the last section because it's a lot less you just have to think a lot less, I feel. Like honestly, like I feel like you just have to look at a term and then be like, you either know it or you don't. And if you don't know it, like you can still work around it if you know the other ones, right? So it's like, just learn the terms and then go for it. Um, Andrew says, I was thinking cognitive dissonance too, because yeah, I don't know the other, and the title of them does sound like they work. Yeah, if you don't, so like we did with cars last section, process of elimination is the way to go because sometimes the right answer won't sound like the right answer, but I don't think here the right answer tends to sound like the right answer, but you really just need to know your vocabulary for this section. Um, and I think it shows that I believe that this section was only added in 2015. And it's like before that they didn't have this section. It's just a strange, I don't know, it's kind of a weird section, but I don't like it and I don't hate it. It's like it's not, I feel like it's very fair. It's straightforward and it's fair. So yeah. Okay, so this is the second part. And this part is quite tough if you haven't had experience with it. So I'm going to try to expose you guys to, so what is this? Experimental design. The passages that you get in this section are going to be very behavioral science based. So what does that mean? They will give you like some kind of background, some kind of setting, and then they did some kind of study in that setting, and they'll show you like a table or something, and then they'll just ask you a bunch of questions about the data. And so like your goal here is just to like be able to understand an experiment and be able to understand um be able to understand an experiment, how to manipulate it, and how to interpret the data that they gave you correctly. So we're going to work through a little exercise here. And I want everybody to really think about it because it will help you a lot if you go through this. Let's say that I don't know, we're in the 1800s or something, and we don't really understand bacteria yet, and we're like, somebody's like, okay, what if washing our hands with soap reduces the bacteria that we spread around, right? If we were thinking of this like hypothesis, how would we design an experiment to test this? And so what could be like the independent variable and what could be the dependent variable in the situation? I want you guys think about this for a minute. Think about how you would design an experiment to test this hypothesis. because if you can design an experiment, then you can manipulate the experiment. And what you're doing on this test is manipulating experiments in a lot of cases. So just take a minute, think about this, and then then I'll ask, like, what do you guys think? Oh, actually, wait, before does everybody know what an independent variable and a dependent variable is? Should I explain that? I shouldn't have assumed.
Go ahead and explain it.
Okay,
Just
sure.
because I think it'll be helpful to everybody.
Sure. So an independent variable is a variable that you manipulate, a variable that is the one that you are kind of tracking and altering. And the dependent variable is the variable that you expect to change in response to your manipulation. I guess that's the best way I could say it. So it makes a lot more sense with an example, which I will explain once. So I'll give everybody a minute to think about how they would design an experiment, and then we'll dig into an example of what an independent variable and what a dependent variable could be in this situation. You think you know, but then I think you know. Yeah, you think you know until you don't know, and then you're like, well, okay. Okay. Does anybody want to throw out an idea of what they think? Yes, go ahead.
Yeah, so I guess also like based off of the definition that you mentioned, the dependent variable would be, I guess, like the amount of bacteria. The independent would then be like washing hands. So we can have a setting where there are two kinds of, or there are two stages of the same surface. So let's say like it's like plexiglass or something. So we'll have like stage A, stage B. For stage A, we'll use our right hand to touch it, measure the amount of bacteria that's there. And then before we place our hands on stage B, we might wash it with soap or whatever the condition would be, then touch the surface, then, measure it and compare the bacteria.
Great. So I think you definitely correctly identified a good independent variable and dependent variable here, where we have, independent variable would be washing hands with soap, and dependent variable would be the amount of bacteria on the surface. Can anybody explain why the independent variable is washing your hands with soap?
That's the part of the experiment that you're changing.
Yeah, but why are we changing that part?
Oh, but because we want to see the effects of washing with soap versus normal, which would just be washing, which could be the control in this case.
Right. So can you explain that? Well, wait, let me
Yeah.
address the first part of what you said. So the first part of what you said is correct. The independent variable is what we're using to test our hypothesis, right? So our hypothesis here was, will washing hands with soap reduce the amount of bacteria, right? So then we're like, well, how do we test that? How can we test that? Simply, we can try one situation where we do wash our hands, and we try another situation where we don't. Like, like was described before with the plexiglass, right? So yes, so sorry, you were saying something about a control. What were you saying?
Yeah, I guess the control would be oh no, actually the control would probably it would be hands that aren't washed, actually, now that I think about it.
Why do you say that?
Because it's like the standard that you have to, or I guess you could, I don't know. I guess you could put it as either way, now that I think about it. But the control would be the standard that you're comparing it to. So I guess you could have, yeah, you know, I think I'm talking too much. I'm confusing myself a little, but
No, you're good. I just wanted you to like broach the subject. I'm glad that you brought it up anyway, because that's where I was going to next. So that's great. So is everybody getting like an idea of, the difference between the independent variable and the dependent variable? So yes. Okay, so we accurately said the what the independent variable was and what the dependent variable was, I think, right? Because we are using the independent variable to see what the effect on the dependent variable would be. And it seems like, actually no, let's just take a look. Okay. So here we have, so actually your prediction of the plexiglass was like kind of scarily close. We have these little I assume glass spheres, right? And in our independent variable, right, as somebody was saying, we what will we do for our independent variable, right? I think we just mentioned it. I think actually, yeah, you have it in the chat already. Independent variable will be method of decreasing bacteria by washing hands with soap, right? So the independent variable would be like, hey, let's try washing the soap, or washing our hands with the soap. And so then according to our hypothesis, what would be the dependent variable? What would happen to the dependent variable if we wash our hands?
it would have a higher, it have a lower amount of bacteria, potentially.
Right, potentially, right? According to, if our hypothesis is correct, then we would expect to see a lower amount of bacteria. So that gives us the independent variable, right? Now let's talk about controls. Controls are incredibly important. Controls are things that we can, so does anybody have an idea, a general idea of like, what is a control? Why do we use controls?
We use it to like make sure we know what, it's hard to explain. So like you want to get a positive result, like an expected result of the test.
Right. I think Lissa was also wanted to answer. Prevent confounding variables. Yeah, can you talk a little bit more about that?
Because you set controls in order to ensure that it's actually your independent variable that is at play to like the result of your experiment, rather than other factors that you just did not take into account. So something about like correlation
Right.
and causation.
Yes, and so those other factors that could be causing it are what we call confounding variables, right? So if we just to throw out a random example, like let's say on days that I wear red shirts, it's always raining, right? And then we're like, well, is there a relationship here? Does wearing a red shirt cause it to rain? Well, maybe it's just maybe it's a confounding variable. Maybe my red shirt is like a waterproof maybe my red shirt is like just good in rainy weather and I like to wear it, and that's why I wear it. So in that case, the color of the shirt being red is kind of a confounding variable. The correlation, this is more correlative, but I'm saying like I wore the shirt for one reason, but from observing, it looks like a different quality is causing the dependent variable. But basically, controls allow us to get rid of those confounding variables and make sure, it allows us to say for sure, I know that the soap is what caused the number of bacteria to decrease. So what could be a potential confounding variable in this situation?
The soap used.
The type of soap that we use, that's also a possibility. So how would we control for that?
We would make sure that all the test subjects have the same soap.
Exactly. We've eliminated a variable, right? We've eliminated a potential variability. Could have been this person used this soap, this brand of soap, this that would mess up the numbers of bacteria that go down, right? If somebody uses like one of those 99% germ away and somebody else uses like, I don't know, some random dish soap. So that's definitely a good point. Getting rid of the variability in the type of soap, right? What about when you wash your hands with soap, what do you do? Actually, that's a dumb question. Sorry. Let me just say, yeah, go ahead.
Touching the faucet.
Touching the faucet, that's true. Let's say somebody turns on the faucet for you. Then what are you in contact with?
Water. and soap.
Water, right? So water is a variable here, right? Like we are like washing our hands with water and soap. What if we didn't use water? What if we didn't wash our hands, right? We could see, okay, so let me explain here. We have these two terms, positive control and negative control, right? We've been talking about a control in general, right? What do you think a positive control would be? And what do you think a negative control would be? Have you heard this term before, or is it like a brand new term? If it's a brand new term, I can just
In general, I think positive control is you have an expected result. Okay, like I don't know, you give this group one thing, you know the result is this. Like you already have an expected result. So now you know that. Yeah, I don't know how to explain it as well.
Yeah, it's very tough to explain. That's the hard part, right? And if you can't explain it, then you don't actually truly know it. And so you really want to be at the level of like, I feel good about explaining this to the point that so that you can be confident when you're actually answering questions and stuff, right? So a positive control is going to be a type of control where you remove the independent variable. We remove the independent variable. If we remove the independent variable, what does that do for a dependent variable?
It would keep it
Yeah, change.
consistent. Oh, sorry, go for it, Liza.
Yeah, you can go ahead.
I think, yeah, go for it, Tasnim.
No, but both of you can go. I was just getting confused. Go ahead, one of you.
I just said that it would remain unchanged. Like there's no change in your dependent variable.
Right. There's no change in your dependent variable if you don't have the independent variable, right? So then the question is, what would a negative control be, right? If the independent control, if the positive control involves not using wait, hold on, am I confusing myself? Oh, wait, hold on. Positive control, negative control. I'm sorry, wait, sorry, I confused myself. The positive control, what I just described was the negative control. The negative control was the one where the independent variable, yeah, see, it gets very annoying because you have to know the terminology like all the terminology is very similar and can like get screwed up. It's really annoying. Negative control, yeah, so negative control is more intuitive because you just get rid of the independent variable basically. Or like you can do everything. You can do everything in the experiment except just not do the independent variable, right? So that's why the negative control is relatively simple, right? So in this scenario, let's say the independent variable was we washed our hands with soap and then we touched the glass, right? So what would the negative control situation be? The negative control being we don't use the independent variable. And the independent variable is that we use some soap, right? So what is the negative control situation?
So would it be you just wash your hands without soap?
Correct. You just wash your hands without soap because we're concerned about what is the effect of soap on the sphere. And so how does that, like if we were getting data, right, that would specifically tell us the effect of washing your hands with water on reducing the germs, right? So if you were getting values, let's say you had 1,000 germs on the sphere, right? And you wash your hands without soap and you reduce the value of germs to, let's say, 700 germs now. So let me just type it in chat so like nobody gets confused. Or wait, I think I can annotate, right? Somebody showed me annotation last time. Yeah, okay. So let's say that there's 1,000 germs on the spheres. And then, oh wait, no, the spheres are sterilized. So actually there's 0 germs on the spheres in the beginning. And let's say that we wash with soap and that puts maybe 100 germs on the spheres, right? If we wash with soap, it puts 100 germs on the spheres. If we wash without soap, let's say it puts 500 germs on the spheres. If we were collecting quantitative data like this, what would that tell us about the effect of soap?
That it's effective in reducing the amount of germs.
Yeah, even more so than just that it's effective. We can tell how effective it is in a quantitative sense because we have data that we can compare. We can say like, well, washing without soap was able to, you know, we could say that washing with soap is 5 times more effective than washing without soap in a way, right? Like we would have to repeat this and see if the pattern is consistent. But so far, just off of this, if this one trial was like the result of many different trials, we could say that, right? So that's a negative control. Now, so to sum that up, the negative control was the idea of removing the independent variable and seeing what happens to the dependent variable. Now, what would be the positive control? If the negative control is removing the independent variable entirely, then the positive control, which is the opposite, should be what? Any ideas?
I would have said adding it, but that would be the independent variable.
Right, we already added it, right? So let me make this a little bit more specific. Let's say instead of remove IV, let's say negate IV for the negative control. So what can we do? So what would the positive control be? It's close to use, and that's why this one's very tricky because it's like, how do we like if using it is middle of the road, how do we use it even harder? Like, it's like, what is that? What would that even look like? Right?
I would have thought. Oh yeah. Go ahead.
I was just wondering, so would you still remove the independent variable? But
that's dependent on the experiment itself. But you could remove the independent variable for a positive control. You absolutely could.
But because it's positive control, I mean, that's what I was trying to say. Like, you're trying to find, like, your positive control should show a change, a known change in your independent variable.
Yes. So what kind of known changes can we have?
Sorry. I was just thinking out loud for
go ahead, think out loud. What kind of known changes can we have? Right now, these glass is sterilized, right? So what can happen to it? It can have germs on it, or it can what? In the negative, sorry, I think somebody was about to say something.
Yeah, so to be honest, when I think positive negative control in this case, I was thinking negative control is full of germs and positive control is no germs.
Exactly. Positive control is no germs, because the negative control removes the soap, right? So the negative control should have a bunch of germs on it, right? But the positive control should have no germs on it. How can we ensure that the positive control has, wait, sorry, whoa, hold on, wait, did I get confused? You said the negative control was what?
I was thinking the negative control was full of germs and the positive control had no germs.
That's right, yes. So the positive control, how do we ensure that it has no germs?
We could autoclave it, I guess.
We've already autoclaved it in the beginning, right? The spears are sterilized. Now what do we do? How do we ensure that it stays sterile?
Damn. I mean, I feel like we just sterilize this. I mean, we could test to make sure that it's sterile. But I mean, we could use something that that is proven to completely sterilize it. But
I'm telling you it's sterile at the beginning. Now what do we do to keep it sterile?
So use gloves when handling the spears.
What's that?
Use gloves.
Use gloves when handling the spear? You're very close. You're very
Um,
close. You're super close.
Not
Does
touching
anyone
the spheres at all.
not touching the spears at all? If we don't touch the spears, how can germs get on them? And so that's why the positive control is a little bit harder. And they will very often ask you about positive controls, because once you think about it, it makes sense. But to arrive at that yourself is kind of difficult. So let me show you. Oh, no, I need to get out of this. So let me show you, after long last, let me show you guys the actual experiment and stop racking your brains. So we determined the independent variable was washing our hands with soap, right? And then touching the spears. And then this is going to allow us to see when we compare to the negative control. And you can use either of these negative controls, right? Because these are both, I feel like this one, actually, I'm not, yes, this one's less because you're still using the water. So I feel like this is a better negative control. But unwashed hands is also an option because we're not using soap. But this one's like less of, I feel like this is the best negative control here because you're minimizing the confounding variables. So we wash our hands with soap here, and then we touch the spears, and that gives us a certain amount of bacteria. That's the dependent variable that we're looking to see. The negative control is going to be the one where we have minimized the influence of the independent variable, right? We have minimized or negated the independent variable. So negated, we literally removed it, right? We literally remove, if we remove the independent variable, how can it influence the situation? It can't, right? So we remove the independent variable, and now we see what effect that we get. Now, if the negative control is negating the independent variable, then the positive control would be maximizing the independent variable, or at least maximizing the effect of the independent variable, right? So if here we've completely negated the effect of the independent variable by removing the independent variable. But we can't maximize the effect of the independent variable by including the independent variable because we already did that, right? So how can we maximize the effect of the independent variable? Well, we have to go back to our hypothesis. Our hypothesis is we will reduce the amount of bacteria with soap. So how can we reduce the amount of bacteria completely? And the answer is, the simple answer is, touch it in a sterile way, or matter of fact, don't touch it at all. If we don't touch it at all, it can't have germs on it. And assuming a sterile lab environment and everything. So this is absolutely critical, because being able to think your way through an experiment, because the experiments that you get are unfortunately not going to be as simple as this, right? they're not going to be like we washed our hands and we didn't wash our hands. They're going to be like weird gene names and knockout genes and mice experiments, and like you're going to get lost in the sauce when you're reading about this stuff. Being able to take a step back and be like, okay, this is clearly my independent variable. This is clearly my dependent variable. This is a control. This is a what type of control? Well, I see that this control maximizes the effect of the independent variable, so I will say it's a positive control. Being able to think through very simple rules, I guess, being able to think through very simple rules like that is going to help you understand even the toughest of scientific experiments that they throw at you. Because at the end of the day, the scientific method is elegant in its simplicity, right? Like we're really just comparing 2 or 3 different situations with one thing involved and one thing not, right? So it's like, yeah, I think that this is super, super important. If anyone has any questions about this so far or just wants to talk about anything, I would please do, because this is really important. Did anyone I feel like did anyone understand this stuff like before we did this, or like did anyone have like an idea of this? Because like I didn't understand, like I I didn't understand this for a long time until like I sat down. I was like, okay, I'm tired of getting these questions wrong. What is like, how do we do this? And it's like, yeah, I don't know. Like I wish somebody had explained this to me like earlier, because it was super confusing to me. Yeah.
I felt like I have an intuitive understanding of it, but the picture definitely clarifies things a lot. But yeah, I feel like understanding is going to come with time and practicing questions like these. But yeah, the explanation helped, and this image helps a lot.
Yeah.
Also, I like that what you said about the positive control maximizes the effect of the independent variable. I don't know, kind of like, I don't know, kind of like, oh, Eureka, oh, that makes sense. It does maximize the effect of the independent variable, the positive control at least, like, which is very helpful.
Yeah, awesome. Yeah, I think making like it's a deceptively simple thing, because it's simple in that, okay, if you just follow that one rule, it's fine. But it's deceptive in that like actually visualizing how to maximize IV is where like elegant experimental design comes from, right? Like when Natalie said it, I'm sure some of you guys were like, oh, duh, we just don't need to touch the spheres, right? And so that's what that's the kind of thing you may have heard, like, oh, this is such a good experiment, oh, this is such a brilliant experiment. And that's kind of the kind of thing that makes something stand out experimentally. So you don't have to be, the good news is you're not going to have to, for the most part, you don't have to, actually, no, that's not true. I was going to say that you don't have to think of like positive controls like up from scratch, but I remember a very specific section bank question where they're like, which of these would be the correct positive control? So I guess look out for that. Yeah. But at least you have the rule now, right? So do you want me to write the rule, or does everybody have the rules? If anybody wants me to write down the rules, let me know. If not, I will just keep going. All good? Okay. So yeah, that was the scientific. Oh, we still have more. I forgot. Yeah. Okay. So we talked about negative controls and positive controls. Now we have to talk about data interpretation, because you get lots of charts and lots of graphs and lots of tables and all kind of numbers. They love to throw numbers at you here, but it's not as hard as it seems. It's pretty intuitive once you understand it. So one thing that these are kind of plots, and you'll see the little whiskers on the data points, and the whiskers means that like that's the error for the bar. for the point rather. So the point could be, wait, can everybody see my cursor or no? Can you guys see my cursor in the top right over here?
Yes.
Yeah.
Yes. Okay. So these two error bars means that this point is also here and is also here, right? So it means that this ranges anywhere from here. So what does that tell you? These blue segments is the distance between this and this. Since they are so far apart, the points cannot intersect, unlike in the below section. You can see how these guys, if this was over here and this was over here, then they could intersect. What does that mean? That means the top data set is statistically significant from the bottom two data sets. This is going, burn this into your brain, statistically significant. This comes up a lot because they will constantly be, because like as physicians, we need to know in the future anyway, we need to know like results that are statistically significant and results that aren't, right? Like you wouldn't use a medication that doesn't have a statistically significant improvement for the patient, right? So, you know, if you're like kind of confused and you're like, where does this play a role in like, you know, medicine and all that stuff, you know, when they do trials for like, you know, medications and stuff, they will see like, does this have a statistically significant effect on the patient's outcomes, right? And if it does, then it's worth pursuing. But if it doesn't, then you have to take a different approach. So statistically significant things, and again, you can see here within, on the second graph here, you can see the statistical significance within a data set, right? You can see that this first point is not overlapping with the error bar of this last point. So that means that the first point and the last point are statistically significant. So what does statistically significant actually mean? It means that it basically means that the results are this is also one of those things that's intuitive, but at the same time like hard to describe. But it basically means like there's something there, like there's a relationship or there is a causative effect happening there. I guess that's the best way I can explain it. Does anyone want to try explaining statistical significance in their own words? Has anybody heard the phrase statistical significant before?
Yeah, I definitely have in a stats class. I think it's definitely what you said, where it's kind of like the effect of the dependent variable is, oh no, I lied. The effect of the independent variable is like it's pretty obvious, or there's a very small chance that external factors are inducing a change into the dependent variable. So kind of like looking back into the spherical you know, the sphere
Yeah.
experiment. Yeah, like it's like in that case, thank you.
Sure.
In that case, we can say that, yeah, like if we are making the counts and everything, there would be a significant, statistically significant effect that hand washing has on bacterial counts, where unwashed hands would lead to a higher amount of bacteria versus washing, where there would be like a decreased amount of bacteria. And, you know, like we're eliminating any other factors where it's like, okay, well, there are aerosols and there are, you know, X, Y, and Z, like maybe you breathing on it or something. So that's my explanation.
Yeah, no, that's great. We're definitely, so yeah, it's a good that you tied the independent and dependent variable to this. The statistically significant, if a result is statistically significant, it means that, you know, the relationship that you were hypothesizing has a basis to be true, I guess, right? And so we have this thing called the p-value, right? And the p-value is basically the idea that it's another way to tell you if results are significant or not, right? If the p-value is greater than 0.05, then it's not significant. And what not significant means is that you can't say, it's not enough to say that there's a relationship between those two factors, right? If the p-value is less than 0.5, then there is significance there. Like we can say there is a strong It's again, because I'm using loose terminology because it's difficult to always be 100% compliant with terminology. But basically, we're saying that there is a relationship there. And so what role does this play in MCAT data interpretation, right? Well, I didn't know this before I studied for this, but this little asterisk here tells you that, if we're looking at the left one here, we have P7, P14, P21. And we see that this line is heading over here and then covering P14 and P21. What do you think that this whole thing means? Anybody have a guess? Considering what we just talked about with statistical significance.
There's a there's a statistically significant decrease from P7 to P21. I think.
Yes, that is pretty much right. The only thing is that since this bar is extended, it's P7 to P14 and P21. So we have this asterisk tells you that these results are statistically significant. I'm guaranteeing that this will come up at least once on your MCAT, because it just does. It's because it's so important that you be able to read graphs and be able to understand the information. Never seen the line before. Yeah, dude, you know what's funny? The research lab that I was at, like, they also had never seen this line before, and they were like super confused about the line. And okay, that's a long tangent, but anyways, it was funny to me. I was like, oh, I learned this when I was studying for the MCAT, just randomly. But this line will show up. Is P4? Yeah, go ahead. You have a question?
Yeah, sorry, just to confirm. So there's a difference between P7 and P14 and P7 and P21, but doesn't say, it's not saying anything between P14 and P21, right?
Great question. Yes. Are they saying that P14 and P21 are statistically significant?
I'm not sure.
Well, okay. So the answer is no. Yeah, because the asterisk is between P7 and then between both of these, right? If we look at the one on the on all the way on the right, then we see that it's saying P14 is statistically significant to P21 right here, right? And there is nothing over P7. That means P7 is statistically insignificant or not statistically significant to both of these data sets. Yes, so to answer your question directly, P14 and P21 are not statistically significant towards each other. But P7 is statistically significant to 14 and 21. So as you broke it up into two separate, P7 is statistically significant to 14, and P7 is statistically significant to P21. But this does not tell you anything between P14 and P21. Good point to bring up. So this is something that I personally guarantee that you will see this at some point. This little asterisk thing. And I think, I forgot about this, but I think the number of asterisks actually tells the significance level, because remember we showed the little chart here about like the P05, 0.05, 0.01, 0.001. I don't 100% remember, but I think that 0.05 is 1 star, 0.01 is 2 stars, and 0.001 is 3 stars. By stars, I mean asterisks. Don't quote me on that. I think that's a thing. I don't remember. It just occurred to me now. I'm pretty sure that's a thing. I don't even know what I would Google to find out for you. Hold on. Statistically significant. I'm pretty sure, because I've seen like multiple stars before. I don't even remember. Oh, yes. Sorry, go ahead.
I was just going to say, like, yeah, I think it does tell you, like, the number of asterisks tells you the degree of significance of how significant it is.
Yes, yeah, I just Googled it, and that's exactly what I said is right, because there's a graph here with 3 stars, and it's saying statistical significance P is less than 0.001. So yes, so if they ask you to compare the statistical significance, what's going to be more statistically significant? Something with 1 star, a relationship with 1 star, or a relationship with 3 stars?
3.
3,
3.
yeah. Because the 1 star would mean that it's 5%, and the other one would mean 0.1%. Yeah, I think, yeah, yes, yeah, okay. So data interpretation, all that stuff. Okay, so the last part is, so, okay. This came up a little bit. I don't remember if it did, but it's good to know anyway, because it's interesting enough to know. This is, so before we were talking about P, right? And P is a measure of statistical significance. Now we're talking about R. R is the correlation coefficient. So now we're not talking about a statistically significant relationship at all. We're talking about correlation. We're talking about something that happens to, and we, you know, the famous saying, correlation is not causation, but you will see correlation because, well, okay, think about this for a second. Think about this for a minute and tell me why. In psychology and sociology, in behavioral experiments, would we more likely see correlation or would we more likely see causation? And why?
Do you mind repeating that question, please?
Yes, and I will put it in the chat. So in behavioral science experiments, are we more likely to see correlation or causational effects? Okay, so this is my question to you, and we can think about that. Andrew, I'm just going to give a minute for everybody to think about it, and then we'll talk about it.
Oh, sorry.
No, it's okay. You didn't do anything wrong. For this part, I'm not going to ask you to explain. I'd just like everybody to put in the chat either correlation or causation. Okay. Anybody want to talk about their answer? Or I can just read what's in the chat. Correlation because there's too many factors to justify causation. Okay, so we talked about those confounding factors before, right? Correlation, then you can start investigating whether the relationship is also causative, right? Why in behavioral science can we not, why do we see correlation? Why can't we just have causation? Why can't we just do it? What are the barriers to investigating like a causative effect?
Each human is different. The differences in each human and also the complexity of our brains.
Yes, the differences especially is a huge one, right? Because, you know, if you're doing like a demographic study, they're not all clones. The people are not all clones of each other. They all have different things going on in their lives and different effects on everything, right? So the other part is oh shoot, you just reminded me of another graph I need to show you guys. Hold on. I need to find this. Oh, this is a good graph. Shoot. How do I find this? Oh, this is a good graph. Oh, okay. I found it. Okay, hold on. I want to show you guys this. Let's put this in here. New slide. Okay. Okay. So what were we talking about? Oh yeah, correlation versus causation in behavioral science, right? Is it because it's harder to control for behavior? Yes, great. It's harder. Yes, that's exactly why. Because if we're in a lab environment, right? I want to, 1 second. If we're in a lab environment, right? We can freely adjust the scenario to what we need, right? And if we're doing like a demographic study or ethnographic study of like the real world, it's not that simple because there are confounding effects that we can no longer control. So in that case, all we can see is correlation. And this is the graph that I wanted to show you guys because this is really cool. We're talking here about validity. Has anybody heard the term validity before, especially in scientific experimentation? Okay, so
I've heard of it.
you've heard of it, but you're not sure what it is?
Yeah, I think I think I kind of understand what it is. It's like if your experiment proves that your actual like if your experiment kind of justifies like the findings.
Yeah, sort of. It's basically like, you did this experiment and you're seeing, does the independent variable affect the dependent variable, right? The validity is that proven? Is that relationship that you claim to have found real? Did you find causality, essentially, right? So, and it describes it right here. So this is internal validity. If a change in the independent variable is really causing a change in the dependent variable, right? And so what do we need to do to ensure internal validity, to maintain causality? Well, we need to do things we were talking about before, like repeated testing, right? If we repeat the test, we can eliminate small, like entropic variables, right? Like small things that we don't even know about. If we repeat it and we consistently see it, that's telling us, okay, this is a relationship that keeps happening. So, the IV must be affecting the DV, right? That's one thing. Confounding variables, right? If we remove all the confounding variables, then we can determine that, hey, A is really causing B, right? And so you can see here these arrows in the bottom. As the experiment becomes more tightly controlled, causality is increasing. Why is that? Why is the experiment becoming more tightly controlled, leading to increased causality? Well, let's think about the opposite situation. What if it wasn't tightly controlled? As the experiment becomes more like the real world, the causality decreases. Why would that be? Why is it that, once if we do an experiment outside of the lab setting and we, change up the variables every so often and we don't have like a good structure to the experiment, then we can't really say that A is causing B, right? Like if my first trial is using obviously if you set up like, okay, let's go back to the hand washing experiment, right? And Natalie had mentioned like different brands of soap, right? Like what if we use different brands of soap as people would do in the real world, right? Then we have introduced a confounding variable that is decreasing our possibility of causality or the strength of our causal argument, right? Because then we're introducing a variable that exists in the real world, but takes away from our ability to claim that the soap is decreasing the number of bacteria. Is this making sense so far? The idea of validity, the idea of essentially all we're saying is, if we get rid of all of the confounding variables, then we are able to perfectly see that an IV causes a DV. The problem is that real life is full of variables, right? Real life is chock full of variables. So if you if you maximize your internal validity and you maximize saying like, oh, this definitely causes this, you minimize your generalizability. Because what if the fact is, what if we use a single brand and a single person and a single type of, you know, glass for the thing? What if we did a single type of, you know, a single source of water and a single sink and all of that, right? We did all of that and we minimized all the confounding variables, right? And then we saw a decrease in germs, right? But how do we know that germs would decrease with a different brand of glass or a different brand of soap or a different person or a different sink or a different water source? Do you see what I'm saying about we have lost the generalizability? We've lost the external validity. And this is just like a push and pull kind of thing. If you maximize your if you are maximizing your causality, you're only maximizing it for this very, 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 very specific scenario. Does that make sense so far?
Yes.
Yeah.
Great. So it's hand in hand, right? A good experiment will be not only internally valid, but also like it can't be fully maxed out. Because if something is completely internally valid, okay, great, you've discovered a very specific thing, but what does that mean to the rest of us in the real world, right? And if something is completely externally valid, well, did you prove any causality at all, right? Because you have so many confounding variables going on that like, what does this actually mean? What's the result that you have? It doesn't help you. So the good balance would be in between, right? Where you are able to say, okay, this is a statistically significant causal relationship that we are able to extrapolate to the real world, that we are able to say like within this amount of confidence could be applied to this real situation or that real situation or whatever, right? So okay, so the reason I brought this all up is to go back to correlation actually. So the reason I did all that is because for behavioral science, we will see correlations because we are studying the real world. We are studying the real world where we don't have the ability to really create a purely causal situation because we just have too many confounding variables. So in that situation, what we can do is measure the strength of the correlation. The strength of the correlation, right? So what does that actually mean? If R is equal to 0, that means that we have data sets that are effectively random. Like effectively, we don't really see a relationship. So if X is like, I don't know, some random, I don't know, if X is like the time that you go to sleep and Y is like the grades that the student gets, right? And if we see this random, then we could say, okay, there is really no correlation between the time you go to sleep and the grades that a student gets, right? Now, if we see this one, R equals positive 0.5, this is showing a positive correlation, a positive correlation. This is saying like, let's say towards this end is like, you know, earlier, right? So if you go to sleep earlier, you get higher grades, right? Now, is that a true statement? If you go to sleep earlier, you get higher grades. Why or why not? Is that true?
It could, but I mean, I think an external factor would be how much we actually studied, right? It would be great if we can all get like 9 hours of sleep and then get like 528s on the MCAT, but unfortunately, I don't think that's the way it works.
Right. So it could be, right? And that's why it's a correlation. We're seeing some kind of link, but we don't know if the sleep is what's causing the grades. This is the essence of a correlation versus a causation. It's always boiling down to cause. Is the X factor causing the Y factor, or the X variable causing the Y variable, right? Now let's look at the most rightmost one. R equals 0.1. We're seeing here a steady trend from sleep. The less you sleep, the lower your grades. The more you sleep, the more your grades, right? Is this showing that more sleep causes better grades? Okay, wait, hold on. Give me 1 second. I'm going to post this in chat, and then after a minute, I want you guys to think about it, and then after a minute, post your response. So I'm going to post a question in chat. Is the rightmost graph showing that more sleep equals better grades? And so more sleep is the x-axis, and better grades is the y-axis. Okay, so don't answer yet. Just think about it for a moment, and then in a minute I'll ask you to post what you think. This is a yes or no question. Okay, I would like everybody to post either yes or no. I would like everybody to participate. I think I got 1, 2, 3, 4, 5, 6, 7. We're missing one person. I don't know who it is. Okay, that's fine. Does I would like to hear an answer from a yes, and I would like to hear an answer from a no, an explanation. Anybody from yes want to explain? Damalari, go ahead.
So I put that it has a positive correlation just because it's a linear graph. We're talking about the one at the rightmost side of the screen, right?
Yes.
Yeah, so I think it has a positive correlation because as we go up in sleep, we get better grades, which in reality I don't think works, but the graph sort of shows that.
Okay. Does anybody from the no crowd want to give their explanation?
Yeah, just to make sure, the question was that sleep is causing good grades?
The question was, is the rightmost graph showing that more sleep causes better grades?
Yeah, I would say no, because there's other things that you could put there that would fit, even though they wouldn't have anything to do with getting more sleep. So I'd say they do have a positive relationship, but I wouldn't say that you could tell just by looking at the graph, because you can't see the other factors. So I'd say it's just correlated related to have a positive relationship, but not causational.
Great. So this is, I'm glad that we went through this. Correlations are not causation. We've all heard it, but what does it actually mean, right? And we get to see that here right now. My question was very specifically worded. It was saying, is the rightmost graph showing that more sleep causes better grades? Anytime you see the word causes, alarm bells should go off in your head, because causation is quite difficult to prove. And you have to have very significant results to prove it, right? Otherwise, people will be claiming that everything causes everything, right? This is a correlation. It's a strong correlation. It's a beautiful looking correlation, but it doesn't prove causation. No matter how strong, we got tricked. No, I didn't trick you. I asked a very simple question. It's just that it's a thing that's quite easy to mix up. And it's only correlation, yeah. So no matter how strong a correlation is, at the end of the day, it's still only a correlation, because, and the reason is, Andrew was alluding to this, it could be that the sleep is caused, it could be, right? I'm not saying it's not right or wrong. it could be that the sleep is causing better grades, but it could also be that somebody who sleeps more is more relaxed in their life and they're just calmer, and because of that they get better grades, or I don't know, maybe like they're very rich and they pay off the teachers or pay students for grades or something. Could be like a whole host of things. All we're seeing here is a correlation. We're not seeing a causation. So I want you to be very aware of that, because this section will definitely like test you like, hey, is this really saying what it's saying? Like, are you sure about it? Are you sure? So yes, correlation is not causation. And now you know what that phrase actually means. What correlation is not causation actually means. Last thing to cover on this slide is these graphs on the left, right? Here we see R equals negative 0.5. What does that mean? Why is it, what's a negative correlation? If we're going with the example that we did before of like sleep and grades, a negative correlation here could mean what?
That would be as one increases, one decreases. So
Right. So
I,
as
I
we,
guess,
yeah, go ahead.
So I guess that would have been like probably to parallel. It would be like as sleep goes down. Oh no 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 no. No, I don't have an example on hand, but yeah. Oh like let's say the more dates you go on, the less money you have.
Okay, yeah, that's fine. That's a negative correlation, right? The more X increases, the less Y is, right? So that's the only difference between a positive correlation and negative correlation. But this is also very important because if you mix up, if something is inverse, if something is a what's it called? Is it a direct relation, an indirect? No, that's not it.
Yeah, yeah, you had inversely proportional.
Oh yeah, that's what it is. Yeah, if something is,
Proportional.
what's the other one? Directly proportional? Or is it something else?
Yeah, I think yeah, I think it is. I think it is. I know inversely proportionate and yeah, I think it is
Something
directly
proportional. I think it's
yeah.
directly proportional. Yeah. So in
Yeah.
this case, on this side, right, these are directly proportional because one goes up, the other goes up. But these are inversely proportional. As one goes up, something goes down. This is it sounds simple, but you will get lost as they throw like 5 or 6 different like variables at you. You need to keep track of the relationship between each variable. And if you mix up one of them, everything gets screwed up, right? If you think one is up when it's actually supposed to be down, that's going to be a big problem for you. Okay, so I think that is the last slide. Yes, that's the last slide. So basically today we went over a lot of experimental understanding and a lot of how to study for all these terms and vocabulary and stuff. Anybody have any questions? Any questions about anything really?
So I had a quick question just with the whole like I know that we went over it the very first week where we were talking about kind of like schedules and resources when it comes to like studying for the MCAT. My question is because I know that there are like flashcard sets that are good for this too. So is it enough to just kind of have Anki and UWorld as like and then of course like the AAMC material to do well on the MCAT, or is that kind of like bare bones?
No, that's enough. I mean, that's what I used. I used UWorld, I use the AMC material, I use the Khan Academy material, and I use Anki extensively. But the thing is, they're all addressing like different. They're all the roles of everything is different, right? So basically, you need to have a good source of content to easily learn from. You need to have something good to help you retain the information, which in this case would be flashcards or Anki. And then you need to have a good source to practice from. So in this case is UWorld, Khan Academy. Obviously the best stuff is the AMC stuff. Then the second best stuff is like UWorld and Khan Academy are really on the same level to me, to be honest. Yeah, and then everything else is just like, third-party stuff. Honestly, it's not, don't fall into the trap of like the quantity. It's really about the quality of what you're doing. It's really about, am I working on things that I can learn from? And Anki, even Anki is like, even doing too much Anki can end up being like a waste if you are just like hashing over stuff that you already know when you could be doing stuff that you don't know, right? So that is good enough to, no, I wouldn't say that's bare bones at all. In fact, I would say like that's the core foundation. Anything else you do on top of that is a little extra. Were you here for the session where we went over like the scheduling and stuff?
Yeah, I definitely was, and I appreciate you mentioning that because I do remember that when you were talking about the scheduling, we went over like the different examples that the AAMC used on the essentials guide.
Mhm.
Because the way that I see it is that like, yeah, you know, like UWorld also, they provide ridiculously thorough like explanations when you get something wrong, so you can use that to like reinforce content, and then like, you know, Anki spits at you like just like a ton of content as well. Only because honestly, like, I don't know about everybody else here, but my attention tends to kind of like uh it drifts if I read
Wanders,
it
yeah.
too long. Yeah. So that's why I was thinking, you know, like maybe I could use those things and then the AAMC just to like be efficient and yeah, just have the stuff that I need.
Yeah, textbooks are definitely Alyssa, I saw your question. I'll get to you. Let me just finish this. So what I was saying was textbooks are definitely, like I said, just low yield. Because you're just passively reading and it's tiring and it's boring and you're not learning, you're not retaining anything. The quickest way to get through the material is read some quick notes on it, read like, read something quick, or honestly, like for the honestly, like for this section, in some cases you could just start doing flashcards, like because there are pre-made flashcard decks, and I'm happy to share my the deck that I was using. If you guys are using Anki, I just have to figure out how to upload it, but I'm happy to share my deck with you guys. And honestly, like for something like this, I feel like it'd be different from person to person, but I feel like I could learn from the cards themselves rather than like even bothering with textbooks. But honestly, that depends on you. I would never say like never use textbooks, like because you need to prime yourself. You need to like get into it in some way. And then you definitely use Anki. The learning happens with the flashcards or with the Anki. Okay, so I'll find a way to upload my thing. I'm not sure how to, but I'll figure out how to do that. Okay.
Thank you.
Yeah, no problem. Lisa, go ahead.
Oh, my question is also along the same line as what the applicant asked. So you would recommend like to start UWorld as early as possible, like while I'm still doing content review? Because I was like trying to think like maybe I should just like save it at the end when like the exam is closer, but I'm really tempted to like just get on with it.
Oh, were you here when we talked about scheduling, or
I think was that the first or the second one?
I think it was the first and the second one. I broached
I-
somebody asked about this topic and I answered it, but
yeah,
just
I
curious
missed
if you
that.
heard or not.
Yeah, I
Okay,
think I missed that. Yeah.
okay. So let me answer this. So yeah, this is a great question. The idea of content review is a misguided idea, unfortunately, because you don't learn if you don't do practice problems and if you don't do active recall. So I know a lot of people spend like a month or 2 months or 3 months like learning all the material and then maybe doing some flashcards and stuff with the idea of like, okay, once I learn everything, I will start doing the problems, right? This is a bad approach because you won't remember the stuff that you did in the content review if you don't actually actively utilize it, unfortunately. Even if you do Anki and I'm speaking from experience because it didn't work for me when I tried it. Even if you do Anki to memorize, even like let's say you do your content review phase and you're using Anki and you successfully 100% memorize everything and you have no retention loss from content review phase, which is obviously impossible, but theoretically, let's say we did that, right? That's still not going to be as good as interspersing with questions because Anki is only showing you one way to understand the material, right? It's a very simple call and response, right? And it's not going to challenge you to manipulate and synthesize the information in the way that practice problems do. And I think I had said something similar to this before. Like I said something like, would anybody be happy about going into a midterm having only read like the textbook? And everybody said like, no, because it's only by doing practice problems and doing flashcards that really helps you understand the material. So to your specific question of should you dive into UWorld? Yes, as soon as possible. Yes, the answer is, if the question is, should I do practice problems? The answer is yes, do it right away, as soon as possible, because that's going, not only is that going to give you ideas of where you're weak at and what you need to focus on, it also gives you like, oh, this is a concept I can make a flashcard out of and review consistently. Yeah, you don't want to save it for the end because there's never enough time. Also from experience, if you save stuff for the end, you're gonna be like, wow, I had like 2 months earlier that I could have started this. I could have spent more time with it. Yeah, I would definitely say your temptation is leading you to the right way. Start doing UWorld and stuff. Start doing. That's why I said I recommended everybody to start with the Khan Academy questions. Were you here for the scheduling one?
I was there. Yep.
Okay,
Yeah.
you were there. Yeah. So I had recommend everybody, like even before you watch the videos, just do the questions and you will immediately be able to tell, I know this or I don't know this and I need to watch the videos or I need to read an article or something from the content outline. Okay, yeah. So do you have a further question?
Nope, that was it. Thank you.
You're welcome. Great. Cool. Anybody else?
Yeah, I don't really have a question. It was more of what can we tackle like for the next topics?
What can we what for the next topics?
Like what things can we tackle for the next topics?
Oh, are you asking like what can we do in the next session?
Yeah.
Gotcha. Right. So here's where I'd like to ask you guys, what do you want? And so we kind of broached Anki today, but I didn't talk about how to set it up and everything. Okay, can I want to know just how many people here plan to use Anki or are already using Anki? Like it's just a yes or a no, or a hand raise. Yeah, that's fine too. Yes. 4 participants raised their hand. Andrew's using it. Christina's using it. Okay, it seems like actually a majority of people are using it. So in that case, like, would you guys like to do you want are you guys already using it? Or are you planning to use it? Because if I do a thing where I show you guys how to set up Anki, I don't want to like waste time for people who are already using it. Some people are already using it. So in that case, okay, a couple of people are already using it. In that case, you know what I'll do? I will, this is so hard. You only know how to use basic and closed feature, but beyond that, that's pretty much it. Yeah, I mean, that's really mostly what you need. Do you guys want me to talk about it in a session or like record a video and just upload the video and you can look at it if you want to? Let me just put it in your hands because I can't figure out what to do. Record and upload. There are good YouTube videos on how to use it. I just wanted to make like a really simple one that like gets across the main points of how to use it and just how to get started using it. I think recording and uploading makes more sense for this, right? So people can just watch it and do it on their own time. Okay, so you know what? So next section, I think what I want to talk about is the biochem section, because it kind of stems off of what we talked about here with the scientific analysis, the experimental design, because it gets on steroids in that section. Yeah, but does anybody have any topics that they're thinking about, that they're concerned about, that they want to talk about? Or even if you're not concerned about it, like any topics that you're just like curious about.
In psych social or in
No, in
The
anything.
bottom section. Oh,
No, in anything. In general.
Now I was.
Andrew,
I mean,
it's not really a, sorry, it's not really a topic. I just wanted to know like how often, because I've sort of heard different things that it's not that much. I shouldn't focus on those sections as much, or at least reviewing the math and the physics as much.
so, I'm sorry, I didn't understand what you're saying.
No, I just wanted to know like how prevalent is the math and the physics on the test?
Okay, I see. So the math is prevalent because the math you're gonna see in everything. You're gonna see like stoichiometric calculations, molarity, all that good stuff. You're gonna see thermodynamic equations. So even that's in the realm of chemistry, but you're gonna see math everywhere. So you have to know your basic math manipulations thoroughly. The physics is trickier. The physics is a real sore spot because it's not minimal enough that you can skip it confidently, but it's also not such a huge, I think it's like 15 or 20%. It's not a huge thing that, you know, like the annoying thing is like you could skip physics and then it's just a game of luck. Like, do you have a lot of physics on your test or do you not? Because they don't give the same amount of physics, same as they don't give the same amount of orgo. I remember one of my friends had like a 7-question organic synthesis, and you know, you don't always see that. You just don't. Like, so it's the same thing with physics. It's tough because it takes a lot of effort. Physics especially takes a lot of effort for potentially minimal gain. That's how I'll say it. But also if you skip it, it could hurt you. It's really tough. You have to make a decision based on the time that you have available to you and to your comfort with the material. I would say like at least knowing all of the equations is where you should start. Like knowing the physics equations is a strong enough baseline that can carry you through like most physics questions. And then after that, you can consider like, okay, let me try to understand like Newtonian mechanics, or let me try to understand I don't know, Bernoulli's principle or whatever. Like, because understanding physics is hard. It's not easy. Yeah, thinking about it now, I think I would just aim to like know your equations and units really well before, and like even if you know that maybe you'll get like some conceptual physics questions and you just miss them because it's really hard to know that stuff unless you have the time to do it. Does that answer your question?
Yeah, it did. Thank you.
All right, welcome. Yeah, anything else? Is everybody good with doing bio next week, or do you want to bring up anything else? I don't know. I think we're making good progress so far. I'm curious, like how's everybody like going through their MCAT studying right now? Since have you used anything from these sessions so far, or like stopped doing anything or something like that? I'm just curious like what everybody's up to. Bodied by a practice test. Car session was super helpful. Good. Oh yeah, Damalari, I remember you wanted to see I was so sad that you weren't here last time because you specifically requested cars. So the good thing is I recorded it and I'm gonna upload it to YouTube once I get that figured out. And then it was I like not to toot my own horn, but I think it was a great session because like just because of how people like were able to like see the patterns and everything. So hopefully you'll get to see that. Started using UWorld. Yes, so UWorld is super great. It's really good. It's great. It costs so much money, but it's just worth it's just worth it. Still struggling, but definitely stopped the reading books for content and beginning to use Anki. Yeah, that's a good move. That is a good move. Yeah. Just about to dive into practice based off what you said because I'm so worried about content, but I can't retain the knowledge. So that's the thing. Like I remember somebody had told me like, when you're like, oh, I feel so unmotivated, I don't want to do anything, right? And it's like somebody had told me at that point like that I had it the wrong way. It's not that motivation leads to action, it's that action leads to motivation, and like it's just a cycle. So for you, it's not that you need to master the content so you can do the practice. You need to practice so you can master the content, right? So you gotta that's how you learn the content. Yeah. Also the practice test last week, it wasn't good. You guys, so I know it's hard. It's hard to see like, tough scores when you do the practice. And as same here. I started from below 500, but trust me that it's worth it when you see your score start to climb. And you will see that once you start, you'll make the most gains initially once you just learn more content through Anki and through whatever you're doing, like videos or documents or whatever. And then you'll make the most gains with learning how to answer the questions like we did for cars and stuff. We're in here for the first meeting, but how long did you take for MCAT studying, if you don't mind me asking? So I studied after I graduated. And so I think I did it for about like 6 months. I was just working at the same time and studying at the same time. And it got pushed back. Initially, I was only going to do 4 months, but it was around the time that was COVID. So then I couldn't get a seat for like ages. I think they canceled all of them. And I really wanted to get it while it was, I don't know if you knew this, but there was like a shortened COVID version of the exam that was like not 7 hours long. And I thought like, oh, yo, this is like, yeah, I want that. I want to like hurry up and like get this over with. And then, but I couldn't get it, which sucked. So then I got it afterwards. Yeah. But again, the amount that you study is really based off of your own baseline, right? Like, a non-traditional person is going to need to spend a lot more time than somebody who like has been involved in research forever and like is familiar with a lot of these things. Yeah. Oh wow, it's actually almost 7. I didn't even realize. Oh shoot. Oh man, I wanted to do a practice thing. What to do? Maybe next week we'll. You got time? Do you guys want to do a practice one? Oh no, oh shoot, no, I actually have something else to do. Shoot, sorry. Okay, maybe next week we'll start with, yeah, we can do it next week. We'll start with one of these psych soc passages so you guys can see how to go through it like we did with cars, and then we might dive into biology right after that. Okay, dokes. Yeah, glad to hear from everybody. Good to hear everybody's doing well, progressing on their own journey. I will figure out how to upload my Anki. Yeah, I'll have to do something with Anki. Okay, I know what to do for next time. All right. Yeah, no problem. Thank you for being here, guys. That's about it. Any other questions, you can email me or post in the chat right now or in the group chat. All good. All right, you're welcome, guys. Good night. Good night.
Good night.
Good night.
Good night.
All right. Andrew, how you doing?
Really good.
Really good. Good to hear.
But yeah, I needed something to do, so I'll head out. But thank you so much. That was great.
Yeah, no problem. Yeah, I was about to like, I wouldn't mind spending another 30 minutes going through it. I just realized I have an assignment to do.
Oh, sorry about that. Sorry.
No, I'm not saying. I just realized. I was like, oh wait, I have something to do at like midnight. I was like, oh, let me go do that. Yeah. No, that's on me for being a procrastinator, not on you.
Nah, don't even worry. Don't even worry.
All
Bye.
right.
That sounds awesome. So I'll see you next week. Thank you so much again.
Yeah, no problem. All right, see you, dude.
See ya.